Hey guys, welcome back. In this video, I'll be attempting to solve a P0303 or P0300 cylinder misfire code. So let's talk for a second about what I've been doing to try to figure that out. So far, I've done all the basics. I replaced all the spark plugs. It's mostly coming up as 303, which is cylinder 3 misfire, but occasionally it comes up as P0300, which is multiple cylinder random misfire. So to diagnose, after I changed the plugs, I moved the cylinder 3 coil pack over to the other. I've inspected all the coil packs. I've looked thoroughly through them. All the springs look good. Everything looks good. Resistance across the prongs also is around what it's supposed to be as well. Yesterday, I took apart this entire section of the wiring harness on top here. You can see here that this plug gave me a real hard time. But anyway, it goes all the way down to the EGR, and that's sort of the top part. It does EGR, high pressure fuel pump, two main plugs. The big fat one here is going to your fuel injectors, and then the other four on top here, these all flow through this right here. And also you've got your camshaft position sensor and your high pressure fuel pump, and then it also goes down to your EGR, like I said. But your wires for your coil and plugs are all coming from here. And you should understand that if you ever try to diagnose this, the wire in the center of each of these plugs is your ground. And so you have your grounding, which goes here, which is grounded to the engine. So I cleaned this up extremely well. You can see where I've scratched that off. And then down on the bottom, it's also connected right here. Also, this blue wire that I've got tucked in here in a few minutes, I'm going to add some ring terminals to the ends of this blue wire. And I'll run it back behind the battery box. And I'm actually going to tie it in with this ground right here to have just some extra grounding. So extra grounding for any wiring component in this sort of system does not hurt at all. It's always a good thing. And in fact, in the Focus ST platform, that car had grounding problems and a lot of CAN bus communication problems that led to errors when it would get hot. There's been lots of threads in that world of how to take that wiring harness apart and fix some of the problems, which I did when I had that car as well. But for now, the other big thing that I'm checking is spark plug gap. And that's because everyone who runs slightly increased boost on this car or radically increased boost says that gap is super critical. And I was running 0.028, and I am right now in the process of making sure that I step that down to 0.026. So what that means is the filler gauge for 0.028 will not go in, and the 0.026 filler gauge will just barely go in. And that is what I'm doing right now with this little gap tool, which is a very convenient thing, which in my opinion is quite a bit better than just like one of these old guys like this, or one of these guys like this. So if you ever see these, well, go get yourself one of these on Amazon if you really want to get into the detail of checking your plug gap, because it's a better solution. So that's where I'm at right now, and I'm going to keep going to try to get rid of this P303 code. P0303, sorry. All right, let's slow down for a second. So my last issue with my body control module code, I jumped in and I threw parts at it before I diagnosed very well. And so this is a classic mistake that a lot of like shop mechanics do, and of course DIY people like me do. Throw parts at something until we fix it. So I already spent money on spark plugs. I don't want to keep throwing money at this problem to fix it. So I want to take some time and try to do a better job of diagnosing. So let's think about misfires for a minute. It is true. So when you have a misfire, it's going to be one of three main things. It's going to be air, fuel, or spark. So I did already look at the spark plugs, and I rearranged the coil and plugs, and I looked at the wiring that affects most of the spark plugs, and I even added some extra grounding. So that's not solving it. I still have the problem. So at least fuel and air. This is a sore subject for the Mazdaspeed community. If you search Mazdaspeed 3 misfire code, you'll find 30 threads on the subject. And CoursePort has a great write-up on their site. I'll post that down in the description. I'll post a link to it. But they have a great write-up on their site that talks about the most common things to go through to check. So, it talks about injectors, injector seals, possibly even your fuel pressure relief valve, your pump or the wiring, On the air side, it talks about a malfunction with your mass airflow sensor, your manifold absolute pressure sensor, the wiring, or even possibly tuning. So what we're going to do now is, so far I've been using the access port in order to understand these codes, right? That's how I know I have a P0300 or a P0300. I'm pulling the code with the access port. So, the access port's a real powerful tool, and it lets you monitor a lot of OBD2 parameters that are sort of already set up. But there's still more detail into the diagnosis that you can get into with different tools. And so I actually purchased a pretty high-end bidirectional scanner in hopes that it was going to be able to do a fuel injector test, but it didn't work. So in fact, not a lot of bidirectional scanners work on this car, on this ECU. If you're out there in the world and you know of a bidirectional scanner that works on this car, please let me know in the comments, because I'd love to pick it up. I spent around $600 on that X tool that I bought, and I sent it back and I already got a refund for it. But one thing that is free that will provide some level of diagnosis is going to be Forscan. And so Forscan is free. You can go out there and search it. I'll put the link to it also in the description. But it's a pretty simple application. And this is just a Surface tablet here. PC, basically. I'm going to attempt to load it up. Actually, I've already got it loaded here. And so this is what, essentially, this is what Forscan looks like if you can see it on the screen. I don't know if you can see it or not. But it is a real simple platform. To use it, it can work with a Bluetooth linked OBD2 module like this one specifically, OBD Link MX. But I think it's a lot more stable if you just use a hardwired one like this. So this one is a lot more, you may have drop issues with this or communication speed issues with this, but this one is going to be solid every single time. This is available on Amazon. I'll put a link for that in the description as well. So yeah, so let's get into it. I'm gonna go ahead and hook up Forscan, and we're gonna do some analysis using Forscan, and I'm gonna kind of show you sort of the more detailed information that you can see using what's called Mode 6 one here. And if you look in, you can actually see in the tests. This is what Mode 6 data looks like when it comes up. But I'm gonna do some screen recording on here and show you how it works. You're basically just going to hook this up, clear off some codes, start, have a look, and then do the process over a couple of times. Alright. Get our USB plugged in. Got our OBD2 cable connected over there. Got our USB plugged in. We're going to go ahead and turn on accessory, get everything on. Okay, now that we're connected, the first thing we're going to do is it starts out on the little icon in the upper left, which is communications with your car, with the vehicle. In the very lower left, there's a little connect to the car thing there. You're going to click that lower left icon, and it's going to go through and it's going to say, please make sure you got your connector connected and your ignition is on. Car not running. It still works with it running for this by the way. And so for this part turning on, it'll ask you if you want to use maximum speed, and you say yes. And I've already saved a profile, so we're going to go ahead and go back to my profile I've saved. You don't have to save a profile if you don't want to. So now that you got that, you can see right away you're getting some information, and right here it's telling us, hey, you've got some DTCs at least. You get a DTC for P0300, which we already know about. So what we're going to do for this little experiment here, demonstration, is so this initial module, what shows us here is like basically a scan and all the modules that it's talking to. You can see it's talking to ABS, RKE, the BCM, your instrument cluster. It's talking to all these modules. So that's good because you can communicate with the modules and see what's going on with them. Like you can even click modules and see which ones it can see. So we're going to go to DTCs. The lower left here is read the DTCs, which it reads it. And it even tells you like it's maturing at time of request, which means it's intermittent. And so I already know that it's intermittent because for me it's only happening when I'm idling, and at least from what I hear. And so I'm using this tool to kind of confirm that with data. And so what I'm going to do for this experiment, so this means this intermittent, it means the light is not actually on yet, but it's stored in the system. So I'm going to clear the codes, which is down on the lower left, it's the second button over. I'm going to say, are you sure you want to do this? And you say yes. And I'll take a moment here, and you see the lower left where it says reset diagnostic trouble codes. And then it tells you turn ignition back off and back on. So I'm going to go all the way off and then back on. I'm going to hit OK. Okay, so no codes. We'll quick read the codes one more time. No codes. Okay. So now there's a lot of features in here, and I'm not going to go through all of it. But below the DTC area is a live monitor area. You can hit the little settings wheel here and choose any OBD2 parameters or other parameters you want to look at. This is not really going to get you much more than what you can look at on your AP if you have that. Below that is a little checklist. We're going to click that, and here's where we can see some of the tests that you can run with Forscan. And for our purposes today, we're using the mode 6 test, which is like about the fourth one down. So we're going to click that, and then we're going to go ahead and hit the play button in the lower left. And this is what this readout looks like. This is freeze frame data. It's taking one snapshot of what's going on right now, and you can kind of see everything that's happening here. And if we scroll down to the bottom, what we're most interested here in is misfire counts. And you've got cylinder 1, 2, 3, and 4. Once we start the engine, this will read live misfire counts. So I'm going to crack my garage open just a little bit right now. And then I'm going to go ahead and start the car. And we'll give it a little rev over 2,000 RPMs. Because sometimes it wants to see that as a part of the criteria to read. So now that I've done that, I'm going to go ahead and click the lower left again, little play button there. And I'm going to scroll down, and there we go. Now we're getting live freeze frame data. So we can see you've got live freeze frame on cylinder 1, 2, 3, and 4. And right off the bat, I don't have any misfire counts. They're all zeros. But if we give our car a minute here to warm up and come to the place where we know it is misfiring, we're going to hit play again, and then down to the bottom, and you see, there we go. There's a misfire count on cylinder 2. Okay? And then we'll hit it again. We'll see we still got one on 2, and now we got one on 4. So we got 2 misfires so far. And you can kind of see with that max column, it's kind of covered up a little bit, but it's a really high number of how many times it's checking. And then it's saying how many times did I count a misfire within that number. And there's a threshold there. It's looking for a certain number of times before it stores the code in the background, and a certain number of times before you're going to see a light pop on your dash. So I'm going to go ahead and hit play again and scroll down and look. And now we've got one on cylinder 3, 2 on 4, 1 on 2, none on cylinder 1 yet. So I'm going to hit play again. Okay. Now I'm going to do a little free revving. I'm just going to rev up a little bit, up to 3,000 or 4,000 RPM, and then back down. And then same again, back down. Okay, we're going to go ahead and hit our little play button there again. Scroll down. There we go. We got 1, 2, and 2 now. Okay, so we've had a very small count of misfires. And by the way, my car is fairly warmed up because I just finished driving home from work a little while ago. And so if I did this when the car is really cold and been sitting all night, I'd have way more misfires by now, because it does it the worst when it's cold. So I'm gonna hit the play button again and go down to the bottom, and you can see, oh, there's cylinder 3 acting up now. I've got 10 misfire counts on it. One more time, 10. You see, each time I'm doing this, we're getting a little bit more information of what's going on. So we got those 10 from free revving, basically, is what we got. And if we give it another second or two, we might get a couple more here. But you get the point how this works. So I'm going to skip here just forward in a couple minutes here in a second. What I'm going to do now is I'm going to go driving and do this whole sort of experiment again while I'm driving. I know you're not supposed to, but I'm going to do it anyway. So back in just a second. running here again. I'm gonna flip over to the DTC area on Forscan. I'm gonna go ahead and hit clear codes, even though you're supposed to do that with the engine. You can turn it off and back on. I'm gonna do it anyway, because I know from experience that clearing codes actually will reset the misfire counts. And so that's what we want to do. So I'm going to tell it, okay, we cycle ignition, even though that's a lie right now. But either way, we're going to clear out the misfire counts. So now after I've done that, I'm going to flip back over to the little checklist thing. And I'm already inside my mode 6 data that we selected before. And so I'm going to go ahead and hit that test in the lower left corner, the play button. And it's going to run. While I'm driving, I notice right away it zeros across the board, no misfires. Top to bottom, no misfires at all. So I give it some time here. I even, some RPM, I'll downshift to 5th. And we're running 3.5, a little over 3,000 RPM. You know, around 70 miles an hour. Let it run a little bit longer. I'll go ahead and hit the play button again. Scroll to the bottom, zeros across the board again. So, and I've already done this, you know, a couple of times at this point. I can tell you, I can sit here and drive for 20 or 30 minutes and keep hitting the little play button, and it comes up 0, 0, 0s every time. No misfires. I won't have any misfires until I stop and let the car go to idle. So, it's certainly not the difference of closed loop and open loop operation, because I'm in closed loop in both scenarios. So I don't know what's going on. I'm trying to figure out if I've got a mechanical problem or a tuning problem. So, but I'm gonna hit the play button again, go down, 0 misfires. I can even downshift to 4th and put it in a boost a little bit. Slow down a little bit there, and then back into 5th, cruising again, back into 6th. And I'll hit the play button again, without killing myself or someone around me. 0 misfires again. So same deal. As long as I'm driving, I'm not getting misfires on the counter. The moment that I stop the car and pull off and slow down and come to an idle, that's when I'll start to see the misfire codes. Every single time, it never fails. So this is leading me on to try to figure out what's going on. I guess, you know, when I see the misfires, I see most of them happening in cylinder 3. I'm wondering like what the inside of my intake manifold is looking like at this point. This engine's only got about 18,000 miles on it since I built it, rebuilt it rather. I'm starting to regret keeping the EGR system, and I'm wondering how much blow by that I have coming from the bottom. So I'm gonna do an oil change, and then I'm gonna start looking at the sensors that measure air. So that's what's next. All right, guys, so moving on with our diagnosis after using Forscan. The number one thing that I want to do is make sure that the sensors that, you know, that measure air, specifically the MAF and the MAP, are good and clean and functioning correctly. Because our, you know, analysis is really showing us that this is probably an air movement problem. Yeah, so here's what those two sensors look like. You know, they're easy to get to, but some things about them, about cleaning them, is really important. So this is my MAF housing for the 3-inch intake from JBR that they sell. But, you know, something that's really important, I've already taken the MAF out of here and cleaned it, but you know, one that's really important is you can see that you know, that thermistor right there, that sensor. And, you know, when you first take it out, when I first took it out, that was a really dull color. And you can see it's a really, really nice, clean, shiny color now where I just cleaned it. Over on the flip side, you know, on this side as well, you can see that runner that goes up into there, right there. Actually, air is captured. This runner right here on the front is not what I'm talking about, but actually on the sensor, you can see that there is actually like another runner where the air shoots up inside the sensor up in there. So you need to use your electronics cleaner, now this stuff right here, to also go ahead and shoot up in there and then clean it out nice and clean all the way up into the top, and then blow it out with a little bit of air afterwards, which is exactly what I did. And at the same time, you also want to make sure that your air filter is good and clean. You know, so I went ahead and sprayed some air filter cleaner stuff on this and sprayed that out with a little bit of water. then I've just been drying it out with a hair dryer and then a little bit of compressed air as well. So also, I'm going to take out the map sensor and give that a good scrub as well to make sure that's good and clean. That's my Core Sport map sensor right there. And that's actually where it sits in case anyone doesn't know. I'm in there right now with an 8mm wrench getting that sucker out. All right guys, so this is my map sensor after just about 15,000 miles of use. So just for reference, see if I can get that to focus a little better for everyone to see. Yeah, that's what it looks like. So yeah, it's really easy for this thing to get gunked up, especially with this engine and this kind of poor performing PCV system. It puts a lot of crap into the intake manifold. So gonna want to keep that clean. Also gonna want to run a catch can, which I also do run a catch can in order to try to prevent some of that from happening. But it does happen. It is in your intake manifold. So yeah, if you're experiencing a problem like this, you definitely want to have a look at your sensors that control and measure airflow. All right, guys, so cleaning those sensors had no impact, still having the problem. I'm going to move on with my diagnosis. I actually, as a part of cleaning those sensors, I got concerned at some point that maybe I had a problem with my tune. My concern was that way back when Farhan at Damon Motorsports tuned my car, I had an actual leak in the intake. And so he actually did my MAF calibration with that leak. And so I thought there was a possibility that there was a table off or something that was causing this. But, you know, it's really just developed over time. It really wasn't doing that, you know, almost never back when I was first done with tuning. So, and I did fix that, you know, intake leak at some point. But the bottom line is that, you know, he says my MAF is fine and, you know, and the fuel trims look great. They're plus or minus 5 at idle, you know, and driving around, and air fuel ratio is meeting targets. So my MAF calibration is fine. So I need to move on with mechanical diagnosis of figuring out what's wrong here. So sensors are clean. I did discover though, you know, looking at the sensor, the inside of my intake manifold does look like crap now. So I am disappointed about the level of gunk in there. So at some point I am going to be taking that off and cleaning it. Possibly even replacing it with a better one. In the meantime, my next thing I'm going to want to check is the most dreaded thing it could possibly be, which is I'm going to do a compression check real quick now. Compression check is a pretty simple check, pretty simple test. Lots of videos on that, so I'm just going to kind of go through that pretty quickly. Get started with getting this top mount out of the way. Next, we're going to want to pull our fuel pump relay. Next, our coil packs. Next are spark plugs. Going in cylinder 1 with our tester. A little bit low. So we have it. I got a little bit low compression in cylinder 3. That is depressing. All right, guys. So I gotta admit, I'm pretty disappointed that I discovered that I've got a little bit low compression in cylinder 3. A couple times in this video, I've talked about how much mileage I had on the engine since the build or rebuild of this engine. So I started, I completed that rebuild in January, February, early February of 2024. I've been driving the car just a little over a year on that rebuild. And so a couple times in this video I said like 15,000 miles, but I checked my records and I'm at 174 now. I completed the build at 154, so it's about 20,000 miles I put on it. So we'll keep that in mind as I diagnose this problem and see what's going on. But for now, I'm not just going to stop and say, oh, I got bad compression and just leave it at that. We're going to keep moving forward to figure out like some more diagnosis of where the leak actually is. And when so taking a look at my compression, in order to figure out, what, as a general rule of thumb, you take the best cylinder and the worst cylinder, you subtract them from each other, you take that number and you're looking at the percentage of difference to the best one. If that is more than 20%, your engine is typically going to be on the way to like catastrophic death. It's going to burn oil extremely bad until something fails. But for me, my best cylinder was 180 psi, worst around 165, a difference of 15 psi. 15 divided by 180 is about 8.3%. So I'm not that bad off when you think about it. 8.3% down. So now what we want to figure out is where is it leaking. This is, forgive my crude drawing here, but this is a cylinder, piston, rod. The ring is going to be right here on the edge of the cylinder. Up top you've got your intake valve and your exhaust valve, and then you got your direct injector coming in right here on the side. And your spark plug coming from the top. So what we're going to do now is we're going to use a leak down tested and some other simple methodologies to try to see if we can figure out where the air is escaping. Because when you do a basic compression test with a tester like this, you're really just sort of checking the integrity of the seal of all this area up here whenever you're going into the compression stroke. So whenever you're going up, your intake valve sealed, exhaust sealed, this whole area should be sealed. And those numbers, that's 180 psi that area will hold. Like in my case, it only holds about 165. So some air is escaping. So we want to figure out where it's escaping. And I'm going to walk through how we're going to check all that stuff in order to figure out our actual source of leak, hopefully. All right, guys, so let's talk real quickly about sort of our tools and our methodology here to get this done. So we've got a leak down tester right here. Yes, this is the Harbor Freight one. It's not the best in the world, but I think it's going to be able to get the job done for what we're trying to do. You've got your fitting here that goes in your spark plug tube right here, along with the connection to this tester. The other side will go on my shop air right here. And then we've also got kind of a neat tool that I hadn't seen before until recently. This is a TDC whistle. This is to help us determine when we're actually coming up to top dead center on compression stroke. I'll show you how that works here in a few. And then over on the car, we're up on jack stands, of course, so we can access the engine underneath. We've already got a wrench down on the main crank pulley so we can turn the engine over. And then some other things that are really important right now to note. Once we put the air down into the cylinder using the leak down tester, we're going to pull off some hoses and check some spaces to try to see if we can figure out where the air is leaking. So the first one that we'll check will be right here. This is just a line. This is going to your purge valve, and this is just going straight into the intake manifold right here. And so if we feel air going in here and coming out here during the compression stroke when the intake valve should be sealed, that tells us the intake valve is actually leaking. So down under the car, and this makes it even easier if you have a catch can, we've got one of our lines actually off of the bottom of the catch can already here. Not totally off, but like I've loosened the clamp in order to make it easier to pull off the check. And this bottom line goes to the actual crankcase. So if we pull this off and find air actually coming out right there, then we know that air is escaping past the piston ring and coming out through the crankcase. So, which there probably will be a little bit because your rings always have a gap in them, and that's to be expected. But last, we're going to simply check the actual exhaust pipe. So if we go back to the exhaust pipes on the back, and we have a good amount of airflow coming out of them, both of them or one of them, then we know that it's the exhaust valve that's leaking. I suspect this leak is probably happening at the intake valve, given the information we've seen so far, but it could be either one. All right, guys, we're going to start by grabbing our top dead center whistle, and we're going to head over to cylinder 3 hole. We've already got our spark plug out. We're going to go ahead and put this down in the hole, screw it into the spark plug hole. Don't want to make it too tight. Never want to make any compression tester or any sort of thing down in the cylinder too tight, or you'll get it stuck in there and then you'll have a really bad day. And we're going to get underneath the car. Hopefully you can see what I'm doing with the camera angle I got going here. But we're going to turn the engine over. Until we hear that right there. We know that we should be sealed and pretty much at top dead center with that cylinder now. So we're going to remove our tool. We're going to insert our leak down tester fitting tool. Again, remember it's got a rubber O-ring, so it does a pretty good job of sealing itself. We're going to grab our leak down tester. We're going to connect that to shop air. We'll get our shop air turned on. Apologies on the air compressor sound if it kicks on. We're going to crank that up to 120. Hopefully we don't have any leaks. We always want to set this side over here to 0 with our regulator. So we're going to use this says push to lock, pull to unlock. We're going to turn this down until we get that to 0. We want to come back up just a little bit to where we see it move. And this is where the cheap compressor test leak down tester comes in. You buy a better one, you don't have to sit here and do this because the reading is a little better. So basically we're just turning it down until we get it to come down to 0. Okay. Now we're going to take our tester over. We're going to go ahead and hook this up to our cylinder. Okay, we're going to bring this up. So there we go. So we're putting in around 30. And we're dropping down to 10 with that immediately. So we see that dropping. So take that to 20. Maybe we'll keep it at 30 so we get a nice airflow going. Like I said, apologies guys if the air compressor kicks on. But right away, we're going to go ahead and pull off this line to the intake manifold. We're going to see if we can hear air coming out of that, which we don't really hear, actually. That's a bummer. I was hoping for that. Just make sure there's nothing else blocking that line. That's straight to the intake manifold. We can even use a little baggie to hold over this line to see what happens. Like this. To see if there's any air coming out of this line. And there's not. Okay. Put that line back on. We'll tighten our clamp later. Okay, next, we're going to get under and we're going to check that line that comes out of the crankcase, which is this line right here on the bottom of my oil catch can. Stick a baggie on it again. See if we can't see this blowing up the bag. There is some pressure there. It's not a lot, but a little. We did sort of expect that, at least a little bit of pressure. Pop that back on. So I guess the last thing we could check will be the exhaust, which is going to be a lot more difficult. Not really much flow there. We'll turn this up. It's 100 psi, holding 20. You know, guys, I did not think about the fact that, oh, right there, my intercooler is off. I got the big old giant hole in the intake. That is it right there. I didn't need to pull this line off. I have this giant hole in the intake right here. You guys can hear that. Oh yeah, 100%. This is coming out of the intake, guys. Hear that? All I had to do was turn the pressure up so I could hear it. So, that's pretty solid evidence. So just again to clarify, you know, I should have had this plugged, because then I would have been able to tell if this line was leaking from the intake manifold. But I have a giant hole right here. I guess it's actually leaking past the throttle body, which I would assume the throttle body should be closed, but maybe it's not. Maybe the air is enough to push past it. So yeah, I would say that's pretty solid evidence from what I can see that we're leaking past an intake valve. That's where our compression is leaking. All right, guys, so what do we know and what are we going to do? Some things we've learned. Our misfire code is most likely due to a leaky intake valve. I'm kind of relieved to learn that, because I already had some more plans for things I was going to do with the car, and now I don't have to stop those plans. I can move forward, and some of those plans anyway are going to help with this problem. So, but the worst case scenario would be I'll pull the whole cylinder head off, and then I'll just take the cylinder head and send it off to a machine shop to get totally cleaned and have all the valve seals and checked, and have them all lapped and checked again for seals, maybe replace them if I need to. So, yeah, I mean, machine shops aren't going to charge much more than, $500 or $600 for that service, plus the parts. I'll have to get some new head bolts, maybe a couple other things, but overall, yeah, that can be done. I can take the head off with the motor still in the car. I don't have to pull the motor again for that, which is truly painful. Before we get to that extreme, is it possible that the intake leak is linked to just crazy amount of carbon and crap buildup on the intake valve? Not completely possible, but yeah, it is possible. That it is definitely like exacerbating that problem. So I'm going to get in there and clean the intake valves, amongst a bunch of other stuff I plan to do. As I've gotten a Christmas list here written out, of what I'm basically planning, So what we're looking for here is I'm going to take one big time period here, and I'm going to remove the bumper, radiator to core support. I'm going to remove the intake manifold, the high pressure fuel pump, the fuel pressure relief valve, and the AC compressor. While I'm in there, I'm going to go ahead and fix the AC compressor mount problem that I have, where I'm going to go and I'm going to weld, drill, and tap some new holes for that in order to get it completely mounted correctly. It is mounted pretty good as we speak, but I want to make sure it's perfect. I'm going to rebuild the high pressure fuel pump. There's lots of videos on that. Corksport has an awesome video on that, and I'm going to be doing that. And then I'm going to install a new fuel pressure relief valve. I'm going to clean the intake valves. I'm going to clean the runners using a media blaster. And then I'm going to pull off the EGR. I'm going to install an EGR hack in order to try to avoid a check engine light. I'm going to install a new Damon Motorsports water outlet. I'm going to try to come up with a wiring VTS solution to avoid that code. I'm going to install a new intake manifold, replace the radiator core support, and finally I'm going to install a new front mount intercooler kit. So here's a look at all the stuff that we're looking at. I've got this plate for an EGR valve. This is a spare EGR valve I had laying around. I'm going to be drilling a couple of holes in this. One of those will run to the intake manifold, so I'll just tap it into the brake booster line. The other one straight to the air, and that's in order to pull a vacuum on this EGR valve all the time, and then hopefully not get a code. I've seen some other folks on Facebook groups do that. Beside that is a brand new Corksport, well, sort of brand new, close to brand new Corksport intake manifold. This manifold flows much better, so hoping to alleviate some of the problems of extra air going to that cylinder initially. New Damon Motorsports water outlet to replace our EGR valve. Matt was nice enough to send me a couple extra barbs in there as well. Corksport high pressure fuel pump rebuild kit. New fuel pressure relief valve. Got the injector puller in case I need to pull out injectors if I have a problem with fuel injectors, which I don't think I'm going to. And I do have some spare injectors laying around, which I could get cleaned and worked on if I need to. So that is the plan for now. And finally, down over there actually is a new intercooler core that'll be going on once I get the piping for that. So that's ordered and on its way. So that is the plan for now. I'm going to be doing a lot of that probably in the next video that you'll see me working on the Mazda. Yeah, I appreciate it if you've watched this far. I definitely appreciate it. I hope that this P0300 diagnosis can be helpful for people out there doing the steps to try to figure out their problem, because there's a lot of Mazdas with that code. So if you found anything in this helpful, please let me know in the comments. If you have a really good solution for the VTCS wiring, because I knew there used to be a company that used to do the little harnesses that would eliminate that check engine light for you. But if you have a good solution for that, please hit me up in the comments as well. But of course, if you found anything useful here that I've shared in this information, please like the video and choose to subscribe. So help me try to build a following for this channel. So thanks so much, guys, and I'll see you in the next one.